The scenario involves determining the appropriate conductor size for an electrical service. A calculation based on a 275-foot run, 200 amps load at 240/120 volt single phase and a 3% voltage drop suggests a 350 kcm aluminum conductor, according to NEC Table 8 Chapter 9. However, the power company proposes using 4/0 aluminum for the service. There are a few possible explanations for this discrepancy. Firstly, the utility engineer may be accounting for the voltage drop between the transformer and the meter. The initial calculation focuses solely on the voltage drop from the meter to the service panel inside the house. If the transformer is a considerable distance away, the voltage drop across the distance can be significant, impacting the overall voltage available at the service panel. This means that even if the conductors from the meter to the panel are sized to handle the load with a 3% voltage drop, the voltage at the meter itself might already be lower than 240 volts due to the transformer's distance. To compensate for this, the utility might choose a larger conductor size, like 4/0 aluminum, from the transformer to the meter to minimize the voltage drop in that segment. Secondly, the power company may be considering future load growth at the property. Electrical loads often increase over time as people add appliances, expand their homes, or install new equipment. The utility engineer could be anticipating this future increase in demand and sizing the service conductors accordingly. Using a larger conductor like 4/0 aluminum from the outset provides headroom for future load increases without requiring a costly and disruptive service upgrade later on. The National Electrical Code, or NEC, provides guidelines for calculating conductor sizes based on load, voltage drop, and other factors. However, the NEC is a minimum standard, and local utilities may have their own requirements that exceed the NEC. These requirements are often based on local conditions, reliability considerations, and long-term planning. Thirdly, it is possible that the utility company has different acceptable voltage drop percentages from their equipment. For example, they may allow voltage drop up to a certain percentage on their equipment before the meter. This drop combined with the drop on the consumer side could require them to install a larger wire. Fourthly, another consideration could be the ampacity of the conductors. Ampacity refers to the current carrying capacity of a conductor, and it's determined by the conductor's size, material, insulation type, and ambient temperature. The NEC provides ampacity tables that list the allowable ampacities for various conductor types under different conditions. It's essential to ensure that the service conductors are sized to handle the expected load current continuously without exceeding their ampacity rating. Exceeding the ampacity rating can lead to overheating, insulation damage, and even fire hazards. Fifthly, the utility company might also be considering factors related to the specific installation conditions. For example, if the service conductors are run underground in a conduit, the heat dissipation from the conductors may be reduced, requiring a larger conductor size to maintain the same ampacity rating. Similarly, if the conductors are exposed to high ambient temperatures, their ampacity rating may need to be derated. Sixthly, it is possible there was a misunderstanding or miscommunication during the discussion with the power company. It's always a good idea to clarify the reasons behind their recommendation and to ensure that all parties are on the same page. Ask the utility engineer to explain their calculations and the factors they considered when determining the appropriate conductor size. Seventhly, the type of aluminum conductor being used might affect the size. There are different alloys of aluminum, and some have better conductivity than others. If the utility is using a less conductive alloy, they might need to use a larger conductor size to achieve the same ampacity. Eighthly, the number of conductors in a raceway can also affect the ampacity. When multiple current-carrying conductors are installed in the same conduit or raceway, the heat generated by each conductor can raise the overall temperature inside the raceway, reducing the ampacity of all the conductors. The NEC provides adjustment factors that must be applied to the ampacity ratings of conductors in these situations. Ninthly, the utility company might be planning for future expansion of the electrical grid in the area. If they anticipate that the local distribution transformer will need to serve additional customers in the future, they might be sizing the service conductors to accommodate this increased load. Tenthly, the utility company may have specific requirements related to the grounding and bonding of the electrical service. These requirements are intended to ensure that the electrical system is properly grounded and that any fault currents are safely conducted back to the source. The grounding and bonding requirements can sometimes influence the size of the service conductors. 11thly, the voltage regulation provided by the utility's distribution system. Voltage regulation refers to the ability of the power company to maintain a stable voltage level at the customer service entrance. If the voltage regulation is poor, the utility might need to use larger service conductors to compensate for voltage fluctuations. 12thly, some utilities have policies to oversize conductors to reduce losses. Electrical current flowing through a conductor generates heat, which represents a loss of energy. Larger conductors have lower resistance and therefore reduce these losses. It would be prudent to gather additional information about the specific circumstances, including the distance from the transformer to the house and anticipated load growth. Armed with this knowledge, consulting with a qualified electrical contractor can provide personalized advice and ensure the electrical service meets current and future needs while adhering to all applicable codes and regulations.